So there's this concept called big data, right? And man, there are more definitions of big data than, their liver pills. And so as we think about big data, what we wanted to do at the end of the day today was to have a panel where we could have a very intense discussion around the evolution of big data, really look at new forms of analytics. And there's a couple of things that I've learned that as I bring the panel on stage, I really want you to think about. We have programmed our minds as supply chain professionals to really want a definitive ROI. We say we're leaders, but then in the next breath we say, but I want a definitive ROI. And I think one of our challenges as we think about big data and we think the evolution of these technologies is they're small projects with an unknown ROI. And that's a really uncomfortable place for us to be. And so as you think about analytics and you think about big data, I want you to welcome to the stage Bob Bowman, who was with SupplyChainBrain, and he's going to facilitate our big data panel. So Bob, let's bring him on. Thank you very much.
Thank you, Laura. Our job, our mission, is to drive you to drink. I don't know if this has ever happened to you, but many times over the years in doing what I've been doing, I'll wake up one morning and all of a sudden I will hear a term being used that I never heard before. It'll go from nowhere to everywhere. And I will feel as if I went to bed too early and I missed the midnight memo passing out in which it was hereby declared that we are now going to start using this term. Now, this has happened to me with big data. I can't even say when it was, but all of a sudden, it was everywhere. The term was not invented yesterday, of course. Depending on how you define it and what context you put it in, you could trace its use back to the 1950s, the 1970s, the 1990s. In 2010, it started showing up as a Google search term. In 2011, it was added to Gartner's hype cycle of emerging technologies. And in 2012, I think a lot of people would agree, was the breakout year for big data, in which it became very widely used by everybody. And this year, big data was finally included in the quarterly online update of the Oxford English Dictionary. Now, the OED describes it thusly: data of a very large size, typically to the extent that its manipulation and management present significant logistical challenges. Now, isn't it interesting that the OED's definition is essentially a negative definition? It focuses on the challenges and the difficulties of big data. And indeed, the title of our panel today is Big Data, Challenge or Opportunity. Now, we're probably going to do a little bit of complaining today about the difficulties of big data, but I hope what we really come away with is the opportunities, is the positive aspect, is what big data can really bring, the value that it can bring to your companies. Now, I have three extremely distinguished speakers to help guide us through this thicket of what is big data. What I'm going to do first is I'm going to very briefly introduce them, and then I'm going to ask them to introduce themselves and talk a little bit about what is their relationship to this whole world of big data in their companies. Starting closest to me, I have Fran O'Sullivan. She is the general manager for IBM's integrated supply chain, which encompasses all aspects of the company's global supply chain, customer fulfillment, and global supply, which incorporates procurement, manufacturing, and logistics operations, and contributes annual savings of $6.5 billion to IBM. And by the way, IBM is probably one of the chief culprits in pushing the whole idea of big data. The company is now almost structured entirely on that, and you could say that the company was created with the idea of big data in mind, but we can talk about that. Next to Fran, I have Steve DeAngelis. He is founder, president, and CEO of Enterra Solutions. Stephen DeAngelis is a technology and supply chain sector entrepreneur and patent holder with more than 25 years of experience in operating technology and manufacturing companies. Steve held positions as a visiting scientist at the Software Engineering Institute at Carnegie Mellon University, as well as a visiting scientist at the Mathematical and Computational Sciences Directorate at the Oak Ridge National Laboratory. As CEO of Enterra, Steve currently oversees a leading applied science and technology firm that has developed an advanced artificial intelligence platform called the Enterra Cognitive Reasoning Platform. Next to Steve, we have Mani Janakiram. He is a principal engineer and director of supply chain strategy and analytics at Intel Corporation. For 14 years, he managed several strategic projects in factory operations, capacity planning, process control, analytics, strategy, supplier management, factory science, and supply chain. Mani is an adjunct professor at Arizona State University, School of Business, and a visiting lecturer at MIT Center for Transportation and Logistics. So what I'd like to do now is introduce each of you, or have each panelist introduce themselves to you, talk a little bit about what is their definition of big data, because I think it still is very much a developing concept, and how that relates to their day-to-day job. Fran, let me start with you.
Okay, great. You know, it's the way I like to introduce big data, because you can say from an IBM viewpoint, you have volume, you have velocity, you have variety, and veracity. But from a supply chain perspective, what I find is the big advantage is if you have structured, semi-structured, and even unstructured data, but we can now get that together quickly and get it into a dashboard, into a control tower, and not even within your enterprise, but within your suppliers and their suppliers, and on the other side, business partners and clients. Get it to a place where you can start taking action. You know, in the old days, in IBM has certainly got its fair share of legacy systems. It was always, you know, a year project, millions of dollars from your IT shop to just be able to get two systems to talk to each other. This was digit 6 serial number, this one was 8, and you could never get it together. Now, with big data, you can quickly get it together and start driving business decisions. So I think that's what's the most exciting thing for supply chains.
Great, thanks. Steve, you're a little different from the panelists flanking you. Why don't you explain that? Tell us a little bit quickly about Enterra, as well as your definition of big data.
Sure. Big data for Enterra, we sort of frame it in the world of big things, in the world of small things. In the world of big things is what Fran just described, the supply chain in the physical world, and for some of our clients in the consumer packaged goods area or pharmaceuticals, the world of small things at a subatomic level or a molecular level, which allow us to understand the behavioral attributes, for example, of why people like the way certain products taste, or the way your brain will process a food product and how that satisfies a certain type of a desire. But marrying the two together, the world of small things, you know, in the quantum world, in the world of big things in the supply chain, is the area of big data that we focus on as it relates to supply chain.
Thank you. Mani, what is big data and what is your relationship to it?
To me, since we talked about the traditional big data definition, I want to kind of make it a fun definition for big data. Big data is a way to release data that is stuck in database jail, pull it out of there, and make it context relevant and value add. So that to me is what I would look at big data as.
Okay.
I'm going to reuse that. I like that. Database jail.
All right, so we're jailbreaking the concept here today in effect. Why now? Why are we talking about it? Why wasn't it possible 10 years ago, 5 years ago? Is it technology? Is it people? Is it awareness? Is it a consultant's ability to suddenly flood us with a buzz term that we didn't have before? Fran, what's your opinion of why this moment?
Yeah, well, I think I mentioned it a little bit in that now you can quickly get data from different sources and you can get it in one place. And you know, you'll have people on your teams that'll say, well, the quality's no good or it's not accurate. And it's like, well, so what? Is it good enough? Can I get to a point where I've got this data together and I'll do a min and a max range, and it gets smarter, it's iterative, it gets smarter every day. So I think The breakthrough is that you can quickly get data from everywhere. We like to say when we start our projects is start small, think big. And you can start experimenting and you learn as you go. So it's just getting it to a place where you can look at it, see the trends, and experiment and move is what's the technology that's really brought it to start this journey, this major transformation.
Yeah. Steve, what are the factors you think have led to big data being a big topic for you now?
Well, all of what Fran just said is exactly true. One of the things that we saw, though, is that firms are a little bit frustrated with the analytics that they had gotten before, things that were more experiential or anecdotal-based analytics and strategy and looking at market segmentation. If you could truly, from a bottoms-up approach, understand the true nature of the data that undergirds the behavior of your consumer and your products vis-a-vis your consumers, you could get much richer insights as to how your business operates and what are those specific drivers that will help enable your company better. So, we felt that big data is being used today because companies are beginning to understand that there's a whole new realm of analytics and insights that can come from this bottoms-up, data-driven approach.
I feel like I'm in a murder mystery and I'm the detectives and I've got the suspects in the room here and I'm going to identify who's to blame or to be credited for this concept. I'm looking at you, Monty, because of Moore's Law and the increasing capability of your chips to hold more and more and more information to unimaginable levels. Is that why big data is a possibility today?
Sticking with the jail philosophy, the culprits are, number one, technology. As you can see, you can carry enormous amount of data in your pocket today, which was unimaginable even a few years ago. So when you have that kind of data, question number one, you can ignore it, or question number two, do you want to use it? So if I want to use it, next question is, how am I going to use it? That's where the people and the people ability to understand and take the data, convert that into information, information to knowledge, and knowledge to context-based insight is happening today. So when you put the people and technology together, we are now in a mode where we can leverage it and we are finding the context. In this case, the context is supply chain. The question is, it is not solution looking for a problem. This solution always existed. We used them in the past in a limited fashion. How many of us were able to pull, for example, equipment log file data and convert that into useful information for predictive PM? Few of us, not all of us. But today with the sensor technology, Internet of Things, and Steve, you mentioned, Robert, you mentioned the Moore's Law. The Moore's Law is enabling the scaling and the sizing. For example, every 18 months, the transistors are primarily, number of transistors are doubling and the cost is reducing by half. And the size is also reducing equally. So with that kind of a technology, we have information and data where we want it. It's the question of analytics and visualization. Can we get it better? As you said, Fran, at the fingertips. So that's what is happening right now.
Yeah. Well, let me pick up on what you said about the idea of pockets. We all know that companies have pockets, in a sense, pockets of data, but they might have hundreds or thousands of pockets. They might have data distributed all throughout the organization and throughout their supply chain, and those pockets don't mesh. They don't come together. So how do we deal with this idea? Have we successfully come to the point where data can be consolidated in such a way that we don't have these isolated pockets or islands that make it difficult to make any use of? Fran?
Well, the way we approach it is always trying to drive what business outcome are we driving or what business problem are we solving. And when you approach it from that way and make a little bit, as everyone, Laura's been saying, outside in and taking it from the client view, and you bring all the parties together, you really find, okay, well then we need all this data, and you start bringing it. But we've had several projects that have failed. So, I think from our point of view, we call it 3 in a box, that you have to have the very smart business, mathematician, person that's part of the team that can really understand the data and get it clean enough, if you will, and bring it from the different pockets. But you also have to have the business line leader. They have to have ownership. They have to say, this is the outcome or the problem I want to solve, and they have buy-in. And also, this is maybe the ingredient that we didn't always have as strong of a player as you need, but you need to have that transformation process leader involved the whole time, because otherwise, if you don't change your management system, if you don't change your terms and conditions, if you're going outside of your enterprise walls, all it is interesting math. People like it. The people that are comfortable with it, they'll adopt it, but the others don't. So we really you need the line leader to want to do it, and all of the line leaders bring the data in. You have to have the smart analytical mathematician, if you will, but also that transformation process management system person that'll tie it all together. I can give one quick example. We just did it with our business partners, and we were spending all this time negotiating back and forth on terms and conditions. We finally said, we believe in the analytics. We will give you as many returns as you want if you follow our analytic recommendations, and we'll give you full price protection. And we actually reduced inventory by 30%, price protection payments by 75%, and our returns by 50%, just because we believed in the math end to end.
Why is it that we start out talking about technology and we always end up talking about people? That seems to be...
Because people are what makes the world happen.
Yeah. Steve, I saw the phrase artificial intelligence in your description, and I'm fascinated by that as a means of bringing together information, as a means of kind of creating decision-making kinds of systems that can aid and, if not, replicate and even surpass human beings. Is there a way in which artificial intelligence fits into this whole big data picture?
Sure. I mean, one of the things that we found as the next leap forward in big data analytics or big data technologies is to be able to provide semantic reasoning about the statistical analytic. So there's a lot of math involved in analyzing data. We do correlation analysis, we do a priori analysis, we do basket analyses, all kinds of analytic data, but all kinds of analytics that go on. But the problem is putting that in context and contextualizing that analysis for a business outcome within a decision cycle is usually very difficult. Our lineage is as a classified government contractor, and we have a solution we built called Sense, Think, Learn, Act. And it was, how do we actually get a machine to help reason about the result of the statistical analytic, to put it in context so we can take a decision within a decision cycle. Today, it's within that critical buying decision moment when a consumer's in a store and they want to make a decision to purchase your product versus somebody else's product. How do we make that happen? So we built tools, things called like a hypothesis engine. That's a natural language processing tool that allows us to democratically it allows us to democratize the access to big data analytics. So much like Fran was saying, it brings together a SQL developer capability, a quantitative analyst, and a business analyst into one place where you can type in a question that says, hey, what's responsible for the uplift in sale of my product in the state of Pennsylvania, and map the result to the retailers that are selling that product. And the engine will go out and set up a reasoning plan, kick off instructions to a quantitative engine, interpret it, then semantically discover things that you can't find mathematically. So you'll know that barbecue sauce usually associates with grilling as a cooking method, and you put barbecue sauce on proteins. Well, that's obvious to a human, but not so obvious to a computer. So what we tried to do is figure out how to make the computer semantically reason about the result of the quantitative analytic to contextualize the answer within a decision zone that the business analysts would like to have.
Great. Monty, Intel is such a critical partner of so many supply chains. It involves the exchange of information all the time. Forecasts are percolating down from the consumer level all the way down to you, and then all the way up to your multi-tier tiers of suppliers. Are you managing to handle big data in an effective way in your organization as a member of these critical supply chains?
I would say we're trying, because as you can imagine, now when Tony was sharing, we have hundreds of, if not thousands of suppliers that we deal with. Supplier, the question is, if there is a situation like in Japan or in Thailand flood, do we know that our supplier's supplier, who turns out to be a unique producer of one of our component, is out there? How do we know that we have a strategy to deal with that? So those are the kind of information from a risk perspective we look at it. And how we deal with that is, I don't want to call this as a big data challenge, but this is a supply chain risk and resilience challenge that we all are grappling with. We need to know how our map, supplier to customer relationship map, looks like. What are our weak points? How do we know that it is good today and how it's going to be good tomorrow? There are a lot of things that are changing. Technology is changing and the customer behavior is changing. Natural resources, they're different. So keeping track of that in one form or the other and using big data would be great if it can make it happen for us. So that's one of the things we're looking at it. And from a hardware perspective, we want to enable that market where all this information is harnessed, stored, collected, maybe through cloud software, but we will be able to get our hardware out there for those kind of applications as well, through servers and cloud servers.
Fran, of course, your job at IBM is to serve as almost a facilitator of the flow of data among all these supply chain partners. How are you finding that these days? Do you think that companies, your clients and your company, are doing a good job of that, or is there so much more work to be done?
Oh, I think we're just at the beginning of the journey. I think it's, we're starting to see good results, and we have some, especially along on risk management. We have a risk management tool, but it's just, that's why I'm just so excited about this big data and analytics, because you literally, you get smarter every single day. I mean, it's just, it's a journey, and it's, I said it already, we start small, think big, but all of these projects, we actually have we call it a grass community that we've set up, a Lotus Notes community within IBM, and people, it's all voluntary, and it's now, I think we're up to like 10,000 people that are just interested in analytics, and they submit their projects, and we have kind of a little pseudo venture capital firm, but it's just, and you can start to see the business results. So I think it's just, we're at the very beginning of an exciting transformation journey.
Yeah. I wonder if we're getting ahead of ourselves and just assuming that data is in of itself a good thing. In other words, so many companies, in order to make good use of data, even in the days before big data, shall we say the little data age, were worried about clean data, accurate data.
Yeah.
As opposed, so is big data sometimes in danger of becoming big noise? What do you think, Fran?
Well, I have a strong feeling on this. I think that one of the things we've done within IBM is I've now, and it's trying to get this end-to-end view. I also have front office support, so I have quote creation, bid managers, price managers, and so getting all that through, all the way through to have accounts receivable as well. That if we get this end-to-end data, and the only thing you know for sure is everybody says whoever is in front of me in the supply chain is absolutely wrong. The forecast is just awful, and they don't know their job at all. But if you stretch this out from a big data point of view, and you have trust, you have to have trust, transparency, and trust in the system, you can start saying, well, if I'm working on this, this big quote, I can start sensing that demand earlier, and do I start to send signals to start to getting that? And so it's this, to me, the big data, you can get overwhelmed by it, but if you really look at it and you think, wow, I can, if I have this transparency, and I can take all these little buffers out that everybody put in because all they knew is that whoever was in front of them was dumb and wasn't giving them the right forecast. It's amazing the efficiencies you can get out, and then you can get your people that used to be experts in whatever their area. The trick is you have to get them excited about something with analytics and big data, because their jobs as they knew them before are going away.
Yeah. Steve, can you be assured that your cognitive reasoning platform is working on good, clean data?
What you try to do is the way that we work in the supply chains, we build a reference model for a supply chain within an ontology or a knowledge base, and we understand the critical nodes on that supply chain such that we can determine the provenance of the data, the form and structure, and the correctness of it. And then as you bring on trusted nodes within that network, you build an assurance model that has, at your different tiers of suppliers, different set of requirements for their maturity in providing up data. And that helps build your risk assurance model. We call it enterprise resilience management, but it's a way of building a resiliency model for the efficacy of the supply chain and the data being plumbed into the tools.
Yeah. Okay, so we've established that data in and of itself isn't necessarily good unless it's clean. And I think we can also establish that the notion of volume is not in and of itself good if you don't know which data to pay attention to and which is just noise. Monty, how do you handle that at Intel? I mean, how do you cut through this huge amount of big data and manage and figure out exactly what you need to be using? Are you using some kind of a control tower or a dashboard in order to bring this down to some kind of a manageable level that you can make use of?
We have multiple methods for that. What we do is, depending on what we're looking at, are we looking at historic data to see what has happened? Then our methodology is more descriptive. If it is our diagnostic, to see what could have gone wrong and things like that. Or if it is, of course, all forecasts are wrong, but if you want to project forward saying what could happen, then it is more of a predictive models. And predictive models always need to be enforced with scenarios and what ifs. Because as probably most of you know, the famous Dr. George Box, the statistician, said, all models are wrong, but some are useful. I would say all forecasts are wrong, but some are useful, provided you put it in the right context. So we do that, and hopefully with the big data, what we're looking at is going from predictive to prescriptive, like Steve was indicating. So that's how we look at it.
Okay, so the demand forecast isn't dead after all?
I don't think
There's
it
still
is
some
dead.
value in
I don't think it is dead. It is not one pill. It is, in fact, when we do demand forecasting, we have statistical models that churn out based on historic data and everything. And then we have a judge demand process that is pretty much a crowdsourcing kind of a thing. We pull that together, and then we combine them together, qualitative, quantitative, to come up with what would be the right demand look like over the next 12 months.
Yeah. Fran, what use do you folks make of the whole idea of the dashboard or the control tower, which is, I guess, the sexier term now to describe that?
Yeah, I was quite lucky. IBM has a Smarter City campaign, and one of the cities they're helping is Rio de Janeiro get ready for the World Cup and the Olympics. And so they have this big city control tower, and there was all these TVs up there, and they have, what is the water, what are they doing for bus transportation, traffic, and all the things you do to manage a city. And I was looking, I was like, wow, why couldn't we do that with our supply chain? I mean, it should even be simpler. We should be able to go, and I want to know if I have an invoice dispute here, or what quotes are we doing over here? And so we're actually taking this intelligent operations center as the core, and that was done for the cities, and we just did our first release, and so we have this literally a control center, if you will, that is we're going to have, and I want to have it in my conference room, don't quite have it there yet, but maybe the biggest switch on this from the way it is we used to be very, have cadence management driven, and when you do have this new control center and it's based on data, you can actually go to having it be alert driven. So if you set up your business rules, and so you say, everything is green, you can have yellow, green, red, it's very simple. And if it goes yellow, then you start to take action. You automatically send text to whoever needs to know on it, and you can start setting up if you need to have emergency meetings, if it's some type of major risk event. But all of that, we were able to reduce our total metrics by 55%. And the one I love is 17 executive hours a week, not going through PowerPoints and having people manipulate or massage data before it gets reviewed up the chain. And really have your folks not doing reports, but doing the value add that you want them to do as you go forward. So, I think it's getting it to be 24/7 and letting your management system now become just exception-based and alert-driven. You can let your people do creative, innovative things to move your company forward.
Anything that kills off PowerPoint is just fine with me.
So Robert, let me jump on that. I think, Fran, your comment about the smart city is great. If you look at it, factory control, for example, we have control towers. We can monitor any tool, in fact, in any site out there down to the tool level to the process level. What is happening? In fact, we can also make some changes using process control because we're able to mathematically bound, what's the input, what's the output, what's the feedback we need to do. But when you start factoring in going from a factory to the enterprise level with a lot of decisions, ad hoc decisions, people involvement, when that happens, you have a lot of variability.
Right.
And then it becomes difficult to identify noise from signal. And that's where we talked about data accuracy. To me, that's the challenge with making it completely automating it and then letting it run on its own. I know the logistics, I heard that the warehouses can pretty much go automated with Kiva systems and also with like remote vehicles moving things and things like that. But to bring that to the enterprise level from a supply chain perspective, we really have to look at what are the key decisions, where are the insights that can be built into it, how can we connect them all together, and that to me is the missing link today.
It's the future.
One of the things that we had found, very similar to what both my colleagues have said, is we're a solution as a service company. So we actually operate a platform for our clients. And so one of the things that we found in running a network operations center where we manage the client activities through is that the predictive models, it's very hard to predict accurately. So what we want to do is gain probability models that give us very good probabilities, and we bound a set of decisions in a probability model. So you're able to narrow and winnow the choice selection to a small number, and then a business person can make a business decision where you can't accurately get a predictive model. But then what happens is when you experience this and you persist that learning within a knowledge base, back to your AI question, you persist that learning, your next time that you encounter a similar event, you're informed by the result of the previous experience that you had. So it's a very interesting concept where you learn to predict, you learn to use predictive models where it's possible, and probability models where you can't accurately predict everything. So for example, in the supply chain perturbative effect, there is a shock to a supply chain and you want to model out, how do I reallocate production from one factory to another factory, or how do I reallocate inventory from one location to another location so I keep Walmart happy with my consumer. Those are the types of things that run very effectively through a network operations center using these techniques.
Yeah, I like that idea of replacing the notion of, maybe you weren't saying this exactly, but the idea of talking about probability as opposed to predictability.
Right.
If we say you're never going to be able to predict the future accurately, why not just consider it a question of probability coupled with the agility to handle what actually does happen? Well, and that's a good point you make.
I mean, I think this probability models just model open world or real world scenarios. Not everything fits within a perfect box for an analytics, so you have to be able to use technology and analytics to get you within a decision zone where a person can then make an informed choice and then learn from it.
Yeah, but Steve, you do strongly believe, do you, that big data can be a measure of predictive analytics? It's a
Absolutely.
predictive model as opposed to simply a massively valuable way of looking in a rearview mirror.
No,
it's looking forward, not back.
It's completely looking forward. All I'm saying is that as you look forward, real world decisions sometimes require probability-based decision making rather than a hard prediction.
Yeah. Is there any link between big data and the cloud? Did the emergence of cloud technology make big data a possibility, or are these parallel concepts that aren't necessarily related? Fran, what do you think?
Well, I think definitely. I mean, if we look at facilitating our big data analytics multi-enterprise, cloud has definitely been the reason we've been able to do it quickly, so facilitate it. So, all our collaboration with our suppliers and their suppliers is all cloud-based, and actually going the other way as well. So I think it's definitely been an enabler for us to be able to get the data together quickly and start doing the analytics around it.
What do you think, Mani, about that?
I would agree with Fran completely. The age of client server is almost dead, primarily with the suppliers and customers spread worldwide with social media and mobile technology all over the place. How do we get the information fast? How do we share our technology faster. And what is happening, how do we collect that, is through cloud, through SaaS, and software as service, software as platform. So those are the kind of things that are going to improve coordination, capabilities, and also visibility of supply chain.
Yeah. I think this would be a good opportunity to open it up to the crowd, so to speak, the audience. Does anyone out there have a question? And okay, we'll wait for the mic though, okay? Because we are recording this, right? I know all of you have loud voices, or you wouldn't be here today in your positions, but still. Trevor.
So Trevor Miles, Canaxis. Hasn't decision making always been probabilistic, and a key problem was we try to make it deterministic? We try to say it's one number plan, it's one number forecast, but it never was. It was always an approximation and always a guess. So that's a key problem that we've been facing in supply chain for 30 years, is our incorrect conception of how we go about decision making. So anybody want to hazard a guess on that one? But Mani?
I can jump on that.
Yeah.
When we start, for example, loading our factories, it's not probabilistic, it is deterministic. We use solvers. We know exactly what our constraints are. We know what we need to load, and we know what the, where the locations are, what timing it takes. It depends on how good the information or how much confidence you have on the data. So the deterministic model in this particular case works, but where the probabilistic nature comes into picture is, am I really going to be able to start that many wafers from our perspective? Am I really going to get that kind of a yield from my tool?
Exactly.
So those are the kind of things we have to build in.
And what about demand? It was never known.
The demand is, as you get closer to the factory start date, the demand, you kind of move from slushy zone to the frozen zone, right? So when you're frozen, you're going to make it. Given that our cycle time is longer, once we start, it's going to complete. We're not going to end it. Of course, we have postponement and delayed differentiations built into our system, but the demand part of it in a shorter lead time is more deterministic than a longer lead time.
I wonder. I'll just add too. I think if the demand wasn't accurate, but if you know what's coming down and you're probabilistic, you can start taking action sooner. You can dissipate it. You cannot, right? You can improve your profit margins, right? It's just knowing, and it's almost like it's good enough that you can start making smart business decisions. Is the I think what we have today that we didn't have 30 years ago.
Yeah, just want to add on that one. It also depends on the product. Custom products, it's fixed, the order is taken, it's done. Commodity product, for example, we have vendor management, like VMI and consignment kind of things where inventory is bad but could be good depending on how your responsiveness is. So that's how we built into it.
Maybe big data will finally make top executives more comfortable with the notion of probability. Maybe before it would be that they just couldn't handle the idea that something might happen as opposed to what was going to happen, because they have shareholders to answer to and they have a board to answer to. They've got to turn around and say, oh, it's probabilistic. And they're going to get stares from people who say, what the hell are you talking about? Tell us what the number is. So perhaps it's a good thing that we're admitting it finally. Who else?
Well, I was wondering, I was having a discussion with Manny at break.
Mike, Laura, you know better than that.
Well, I am Mike, but I was having a discussion with Manny at break, and we were talking about talent, and Manny, you were talking about losing people on your team and the attack for talent, and I was wondering if you could comment on how this really comes to bear with people that are really strong with analytics and having these big data teams.
Oh boy, big question.
Big question,
who wants
Laura.
to take that?
I think she addressed me, so I'll try answering that. In fact, I do have a model. I call it as a diamond model. Primarily, if I'm trying to hire, the person need to have software skills. The person need to have analytical skills. Analytical skills could be statistics, could be data mining, could be linear programming or simulation kind of background in this case, probabilistic models. And then, of course, some of the communication, teamwork, and leadership skills, and some kind of a domain expertise. Where are you going to find this kind of a person? Probably not in one place. But that's why we have a training package internally, learn by doing, and also connect them with other people. In terms of talent, in fact, this morning I was actually a little bit surprised that we have such a big challenge. Yes, we do have challenges in pockets, but we have great schools. We identify some of the big universities, top 5 supply chain, and then we work with them year round. And we are able to hire the students that we want to hire. And for example, ASU, MIT, Stanford, Penn State, Michigan State are great. I mean, there are others, I'm not mentioning everybody. So if you have a collaborative engagement partnership with them, we go teach classes there. And then we fund them in consortia. We engage the students on research projects. So they know what the company is, internship. And normally our hiring happens after the internship. So when the interns are completing it, we give them an offer. And so far we have been like successful. Where we have had challenges is, like Laura indicated, when an experienced person leaves the company. For particularly deep dive analytics knowledge in terms of operation research or statistics, we have problem with there. We can go hire new students, but getting them the domain knowledge, the business savviness is harder. I completely agree with that part. And we also had challenges in Asia and a little bit in Europe, not a lot. In Asia, we have to work with universities again. And then, in fact, when we were trying to hire professionals in Vietnam, we have to actually bring some of them here, put them in US universities, and they went through some of the supply chain class, training here. So those are some of the methodologies we have used.
By the way, they have to be a people person too.
People person definitely is a soft skill. That's part of the diamond.
Okay.
Absolutely.
Steve, you're about to say something?
Well, we have as a small firm, we have a lot different challenge than IBM or Intel does. We don't have to hire at scale, luckily. So we're able to seek very talented people out of internships, limited internships that we have from people coming out of good schools. But the interesting thing is that I was riding on an airplane to Seattle a couple of weeks ago, and one of the persons on the plane with me was an executive from a very large web property company. And they were saying, they're having trouble we hire applied mathematicians, computational geometers, people who have weird backgrounds. And finding those people is very difficult because there's not that many of them. But this gentleman was telling me that he's having the same challenge because a lot of the people, same kind of folks, are wanting to go to emerging companies because they feel that some of the larger firms have solved the big problem, have solved their sets of problems, and they're looking to go to small firms. So ironically, smaller firms like mine are able to attract people that are coming out of school in a way that some of the larger, I don't know about your firms, but this gentleman was telling me he was having trouble with. But the challenge for us is finding people who are mid-level executives who can program manage very complicated projects and have the types of skills that Manny was talking about at the middle level management level, at the people who can run a project at a client. Those people are very, very difficult for us to find.
Okay. I want to bring this in on time, so I want to get final statements from each of our panelists. Let's give them a takeaway and answer this question about big data. Why is it important? Why should I care? Fran?
I don't think you can be competitive in the future if you don't start to take advantage of it. So I'll say it for the third time. Start small, think big, put together some data projects, and just let the results get the momentum going, and you'll just be amazed. So
great. Steve?
I think that big data is going to drive a wave of transformation in almost every industry. That's going to be bottoms-up, data-driven analytics, and creating those analytics will create a new set of insights to drive your business forward in a way that you couldn't before because you didn't have that knowledge and insight.
And Mani?
Don't jump into it just because everybody is talking about big data. Really evaluate and analyze your situation. Make sure that the people who are jumping into it understand what they're applying it for. Do they have the mix of business need, analytics and visualization, and also how they want to add value. So make sure that you make an assessment before you jump into it, is what I would say.
Well, I don't know what I'm going to wake up and hear tomorrow morning that I haven't heard before, but I think this is actually a term that's here to stay. And we've had 3 fantastic panelists helping to put it in perspective. Would you please give a big round of applause to them?